It's always such an honor to spend time with you and to be together. If you're brand new, welcome to this channel. And I also want to take a moment and just acknowledge you for taking time to listen to something that can truly help you in improving your solving skills. If you're super stressed in solving, the tip that I give are short, concise, or how they can be better to improve your solving strategies. And let's get started to fix the solution for today's problem on homogeneous differential equations. And the topic is from differential equations of first order and first degree. The two problems are so important here. First, we have to solve y squared minus 2xy dx is equal to x squared minus 2xy into dy. And the next equation here is x squared y minus 2xy squared dx is equal to x squared x cubed minus 3x squared y into dy. So here is the solution for the first question here. See here, how to identify this as an homogeneous differential equations. So whenever you look throughout the equation, so there are two variables here, 2. So equally distributed. So here we have to, first of all, we have to take dy by, this is dx. So here is dy and here is the dx. I'm sending this dx to other side. Then this will become y square minus 2xy by, this is x square minus 2yx. 2xy. So for the homogeneous differential equation, I am taking put y is equal to vx. So if I make a derivative on both sides, so for y this is dy by, this is dx. So this is UV rule. For x it is 1. And next if I leave x here, this will be dv by dx. So both are equation 2 and this is equation 1. And now I am going to substitute equation 2 in equation 1. Substitute the values of 2 in equation 1. So in place of dy by dx, I am replacing this one, v plus x into dv by dx, and in place of y, I am going to replace vx. So in equation 1, see, in place of dy by dx, I am writing as v plus, this is x into, this is dv by dx, which is equal to, so here is y. In place of y, I am going to write vx. So this is vx whole square minus 2x into, again there is y here, this is vx divided by. So here is x square minus, this is 2x into, in place of y, I am going to write vx. Clear? And see here, this will be v plus x into dv by dx value is equal to, this is v square x square minus 2v into x square divided by, this is x square minus 2v into x square. Now, if you observe, I am going to take x square common and cancel. So if I take x square common and cancel, see what happens here. This will be v plus x into, this is dv by dx value is equal to, this is x square. If I take common, this will be v square minus 2v. And if I take x square common, this is 1 minus 2v. Now if I cancel these two and see, if I send this v to other side, so this will become x into, so this is x into dv by dx value is equal to, this is v square minus 2v by, this is 1 minus 2v minus v. So this is going to become x into dv by dx value is going to become, see here, this is 1 minus 2v. So this is v square minus 2v. If I multiply, this will be minus v, and this is minus of minus plus, this value is plus 2v square. Clear? And see, if I add this v square plus 2v square, so it's going to become plus 3v square. So this is x into dv by dx value is equal to, this is plus 3v square, and if you see, this is plus 2v and minus v. So this is going to become minus 3v. So this is going to become minus 3v by 1 minus 2v. So if I take 3 common here, so x into dv by dx value is equal to, if I take 3 common, this will be v square minus v by 1 minus 2v. And the next thing, as usual, I am going to separate the variables. So variables and separables. So there is dv here. So I am sending v to one side and x to another side. So this is going to become 1 minus 2v. So this is 1 minus 2v by. So this value is v square minus v into dv, which is equal to, if I send x to other side, this will be dx by x. See here, I have separated the variables. After separating the variables, the next thing what I'm going to do is, so if I take minus common from this, so this will be 2 minus 2v minus 1 into dv by, this is v square minus v, which is equal to 3 times of this is dx by x. So now I am going to integrate on both sides. So if I integrate on both sides, see here the derivative of v square is 2v dv and the derivative of v is 1 into dv. So there is a derivative in the numerator, and therefore I am going to write it as minus log of the denominator, that is v square minus v. Here the derivative of x is dx, so I'm going to write this as log x plus this one is log c. So here this minus I'm sending to other side, so this is going to become 3 log x plus this value is log of this is v square minus v, which is equal to the log c. And see, this can be written as log of this value is x cube plus this is log of this is v square minus v, which is equal to this value is log c. And log a plus log b value is equal to this is log a into this value is b, which is equal to log c. And therefore if I cancel log on both sides, this is going to become x cube into this is v square minus v is equal to c. So here we have substituted, put y is equal to vx here. So then I'm shifting this v to in terms of x. So v value will be, this is y by x from this equation, and in place of v I'm going to write as y by x. So this is going to become x cube. This is y by x whole square minus this is y by x, so which is equal to c. So x cube into, so this value is y square by x square by y by x is equal to c. So this value is x cube. So here if I take x square common, this will be y square minus xy, which is equal to c. And now I can cancel x square and for 2 times. So this will be x times of this is y square minus xy is equal to c. So if I multiply, this will be xy square minus x square by v is equal to c, which is the solution for the given differential equation. So this is how we have to use the homogeneous differential equation. So very simple as usual. How many problems you have to do? That for that many problems, this is the procedure here. For put y is equal to vx. So suits for this, and dy by dx value is this one. So we have to replace y as vx and dy by dx as this one. And after replacing, we have to take x square common and cancel, and we have to shift this v to other side. It will be minus v, and after calculating and sending v to one side and x to one side, and after variables and separables method, we have to integrate on both sides, and after integrating, so this will be the solution. In the final solution, we have to transform this v2 as y by x, so this will be the answer. So if you follow each and every steps, if you note down each and every steps and practice, definitely you can solve by your own. And the next equation here is x square y minus 2xy into dx is equal to x cube minus 3x square y into dy. Every time I need, first I'll check dy by dx. So I'm sending this dy to other side, and this will become dy by dx. So this is so important. X square y minus this is 2xy square divided by. So this value is x cube minus 3x square y. So here is the substitution. Put y is equal to vx. So here put y is equal to vx. So here in this substitution, if I make a derivative, y will become dy by dx value. For x it is 1. So v into 1, and if I leave x here, so this will be dv by dx. So these are the two equations 2, and this is equation 1. And now I am going to substitute equation 2 in equation 1. Substitute the values of 2 in equation 1 here. So here in place of dy by dx, I am replacing v plus x into dv by dx. See here, v plus x into this is dv by dx value is equal to. So this value is x square. In place of y, so I am writing vx minus 2x into, in place of y, I am writing vx whole square divided by. So this value is x cube minus 3x square. In place of y, I am going to write vx. Clear? And therefore, so v plus this is x into this is dv by dx value, which is equal to v x cube minus 3, this is v square. So this is x square into x, the value here is x cube, by this value is x cube minus 3v into x cube. So if you observe properly, so here I am taking x cube common from the numerator as well as denominator, and I'll cancel those. So here the next step will be v plus x into dv by dx is equal to, if I take x cube common, what remains here? V minus 3v square by, so this will be, if I take x cube common, 1 minus 3v is left over. So I'm cancelling these two. And again, see here, v plus x into dv by dx value is equal to, this is v minus 3v square by 1 minus this value is 3v. And now see, I am going to transform, I am going to shift this plus v to other side. So if I shift the to other side, then see what happens here. This will be x into this is dv by dx value, which is equal to v minus this is 3v square by 1 minus 3v minus v. And see, this is x into dv by dx value is equal to, so if I make an LCM, this is 1 minus 3v, this is v minus 3v square. If I multiply, this will be minus v, and this is plus 3v square. And see, this plus 3v square, see here, so if I go like this, see here, this is 2x into vx whole square. So if I multiply, this will be v square and x cube. Here is 2 here, I have to write 2 here, and the next one here also there is 2, and here also there is 2 here, only 2 is there. And see, this will be a 2 value. So here if I cancel plus v and minus v, and see, this will become x into dv by dx value is 3v square minus 2v square is v square by 1 minus 3v. So here in my next step, as usual, I am going to separate the variables. I am sending v to one side and x to one side. So if I send this 1 minus 3v to other side, this will be 1 minus 3v by, this is v square into dv, and I am shifting this x to other side. This will be dx by x. Clear? And now see here, now I am going to, after separating variables, I am going to integrate on both sides. If I integrate on both sides, see here, if I integrate on both sides, this will be 1 minus v square dv minus this value is 3 times of v by this is v square dv is equal to, this is dx by x. Now if I cancel 1v here, this will be integral 1 by v square dv minus 3 times of this is 1 by v dv, which is equal to, this is dx by x. So 1 by v square, so the integration value will be, so if I send minus 2 to the numerator, this will be minus 2 plus 1, this is minus 3 times of this is log v, which is equal to, this is log x plus this value is log c. Clear? This value is log c. So this is v minus 1 by minus 1 minus this is log v cube, which is equal to log a plus log b is log a into b. So this is minus 1 by v minus, if I shift to other side, so this will be log, this is v cube plus this is log x into c. And see, we substituted, put y is equal to vx. So this is the substitution made here. In the place of v, we have to write y by x. So wherever we find v, I'm shifting this in terms of xy. So this will be minus 1 by, this is y by x, which is equal to log, this is y by x whole cube plus this value is x into c. Clear? So if I reciprocate it, this will be minus y by x is equal to log a plus log b is nothing but log a into b. So this is log a into b. So if I cancel for one time square, so this will be minus x by y. This is log y cube by x square into c. So y cube by x square into c, and this will be the final answer for the given differential equation. So this is how we have to apply the homogeneous differential equation. So this is so simple if you follow these steps. Every time we have to follow the same steps here. So we have to put y is equal to vx and dy by dx is equal to v plus x into dv by dx, and we have to transform equation 1 in terms of this. And again we have to take x cube common and cancel, and we have to send this v to other side. And after simplifying, so we have to separate variables and separables method. So variables are separated, v to one side and x to one side, and again we have to integrate on both sides, and after integration this will be the final answer. And both are very equally important. And see, if you note down each and every step, and if you practice, and definitely you can score more and you can get more score. And if you really like, please raise your thumb, pass it on to your friends, and subscribe to this channel and stay connected. Go through the playlist. So many videos are uploaded for your preparation. Definitely it will be very useful, and stay connected, and I'll be uploading a few more problems which are very important, and have a look at those. Thank you so much.